Hi everyone, my name is Jane, and today I'll be presenting my work on modeling and identifying Russian troll accounts on Twitter. And this is work done with awesome collaborators Ishwar, Jackson, Paige, Tyler, Ankit, Libby, David, and Eric. I would like to start off by talking about the motivation of our work. The Internet Research Agency, the IRA, is a Russian company known to engage in online influence operations on behalf of Russian business and political interests. And US intelligence agencies, scholars, etc., have found that IRA created fake accounts called Russian trolls on various social media platforms. So the IRA created Russian troll accounts to organize a propaganda that was conducted with the purpose of interfering with the US political system, including the presidential election of 2016. And so considering the critical role that social media plays within the political system, we thought it's crucial to attempt to find Russian trolls among everyday normal accounts using machine learning. We also take a step further and ask if we can leverage the machine learning classifiers we built to understand what currently active Russian trolls are doing now. And we also ask, are they just software or are they just bots? And if not, what do they look like? And in this presentation, throughout the presentation, I'm going to argue that our work shows that we can differentiate Russian troll accounts from normal accounts using a combination of machine learning and human evaluation. And furthermore, throughout this presentation, I'm going to argue that our work shows that Russian trolls are likely to be active and that they're not just bots. They have various ways to manage their online identities. And so I'm going to start off by trying to show how we try to answer the first question: can we find Russian trolls on Twitter? And so to answer this question, we built machine learning classifiers that were trained on a data set consisted of Russian trolls and control counts. And as you can see, about 1% of the data set was Russian trolls tweets, and the rest, the majority, were of control counts tweets. And the reason why the data set is so imbalanced is because in this paper, we were trying to imitate the task, the real world task of differentiating Russian trolls, which we hypothesize will take up a very small fraction of the entire Twitter American users. And although, of course, we don't know for sure how rare Russian trolls are, we thought it's likely that it's safe to assume that there are small amount of Russian troll counts out there among the entire American Twitter users. So that's the reason why the data set is so imbalanced, because we're trying to imitate a real world task. And I'm going to talk a little bit about how we got the data set. So in terms of the Russian troll data set, Twitter officially released a new data set of about 3,800 accounts that they believe to be connected to the IRA. And among those, we focused on about 2,200 accounts whose users selected English as their language of choice. So the reason why we did this is because our task here is specifically we wanted to differentiate accounts that were trying to imitate American users. So that's why we selected the accounts that only chose English as their language of choice. And although it's a very rough proxy of whether an account is American or trying to imitate American, we thought it was okay enough. And in terms of the control count data set, we assembled this by ourselves. So the initial data set was drawn from a historical 10% sample of Twitter data, the garden host data. And we iteratively refined this data by account's location and activity time. And we ensured that the accounts tweeted at least 5 times between 2012 and 2017, which is the time that the Russian trolls among Twitter data set was active. And then we randomly sampled about 170,000 of these accounts. So to recap, a small percentage, about 1%, is Russian trolls tweets, and the rest of them are control counts tweets, which we assembled by ourselves. And for both groups of accounts, we used the up to most recent 200 tweets. And the reason behind this is because there's a rate limit to Twitter's API. So we struck a middle ground of retrieving up to 200 recent tweets for control counts. And we also did the same thing for Russian trolls. We used up to 200 recent tweets of Russian troll counts as well. And now I'm going to talk about the features which we use to build machine learning classifiers. And while I recommend checking out our paper to see the details, I'm going to briefly explain what each group of features mean. So first is the profile features. Many literature have shown that people manage their online identities through features within the profile. So we thought it's important to include features like number of followers, number of following, bio length, and account age. Next is the behavioral features. This group represents features that are related to the usage of hashtags, mentions, share links, and volume and length of retweets. Next is the stop word usage features. So prior literature has shown that non-native English speakers use stop words differently compared to native English speakers. And so we thought, because Russian troll accounts are managed by the IRA, which is a Russian organization, we thought there might be a difference between the stop word usage. So we calculated the frequency rate of 179 stop words, which we retrieved from a list provided by sklearn library. Next is the language distribution feature. So again, assuming that Russian troll accounts are managed by people that aren't Native Americans, we thought there might be a difference between the distribution of languages. So for each account, we calculated the distribution of languages shown in the recent 200 tweets per account, and we came out with in total 82 languages. And last but not the least is the bag of words features. In short, these are top 5,000 most frequent engrams of the corpus of Russian troll and control accounts, tweets. So combining all of these features and training on the data set that I explained, we built 3 types of machine learning classifiers: logistic regression, decision tree, and an adaptive boosted decision tree. And I first want to mention that accuracy is not the right metric here, because the data set, again, to recap, was very highly imbalanced. So instead of accuracy, I'm first going to talk about the AUC. So as you can see, for across all 3 classifiers, all of them had AUC above 90%. And we also thought precision is also important, because we don't want to have a high false positive rate. In short, we don't want to flag a lot of accounts as Russian trolls when they're actually not. And although logistic regression's performance is slightly lower compared to the other 2, you can see that the 3 classifiers' precision is at least 78%. And so I want to argue that the results of the tenfold cross-validation of these classifiers show that we can roughly differentiate Russian troll counts from a vast pool of normal control counts. And then we take a step further. So we next ask, so we have built these classifiers, can we leverage them to see if there are potential Russian troll accounts out there on Twitter, and can see what are they doing now? So what I mean by is that so far we've constructed classifiers from past data of Russian trolls. However, can we leverage the classifiers to see if there are currently active Russian trolls? And so for this, we would need a new test data set. So for the new test data set, we assembled accounts that recently mentioned famous American journalists on Twitter. And the reason behind this is because assuming that the Russian troll's goal is to influence the conversation about US politics, we thought it's a natural strategy for Russian trolls to contact famous journalists to influence news coverage and shape public opinion. And unsurprisingly, a study has actually shown that major outlets like New York Times had actually used Russian tweets as sources for partisan opinion. So based on this hypothesis, we assembled a list of 57 high-profile American journalists on Twitter, and this was a combination of various Twitter lists. And then using the Twitter API, we queried for about 39,000 accounts that recently mentioned these 57 journalists. And then we ran the logistic regression classifier on these 39,000 accounts, and results showed that about 3.7% of the accounts that recently mentioned the journalist were flagged as Russian trolls. And we don't have ground truth here. So perhaps only the IRA knows this, but we don't know if the flagged accounts are really Russian trolls or not. So we take a step further and conduct a step of human evaluation on the results. We asked 3 raters to independently rate how likely they thought 100 sample accounts, so 50 of them were flagged accounts among the accounts that mentioned the journalists, and 50 of them were unflagged accounts. So we asked them to independently go through 100 accounts without telling them which accounts were flagged or not, and asked them to give a score between 0 to 5, with 5 meaning that they thought account is very suspiciously resembling a Russian troll. And to provide more details, the 3 raters are co-authors of this paper, and they're undergraduate students at the University of Michigan, with one having a major in political science. And we thought they had roughly enough expertise to conduct this task because they had experience of studying the Russian troll data set that Twitter released for about 3 months. So we thought they had enough expertise to observe the accounts and decide whether they look suspicious enough or not. So we asked them to visit each account's page, look at the most recent 20 tweets, also asked them to look at bio, profile image, cover image, account creation date, number of followers, following, etc. And the results show that the Gryffindor's alpha for the 3 sets of ratings was computed to be 0.51, which is not high, but we thought it's understandable considering that the task here is difficult, trying to differentiate accounts that are trying to imitate actual American accounts. The human evaluation results show that the distributions of average ratings given by the 3 raters per account differed between the flagged versus unflagged accounts. So the red line here is the distribution of the flagged accounts, and you can see it's skewed towards more to the right compared to the blue line, which stands for the unflagged accounts. And so you can see that the raters tended to give more higher scores to the flagged accounts. In short, 70% of the flagged accounts had at least 2 raters giving them a score above 3, and about 84% of them had at least 1 rater give a score above 3. So again, this is a very rough human evaluation, but we thought it showed that at least a high portion of the flagged accounts that mentioned the journalists did seem legitimately flagged by the human raters. A follow-up question we also asked is, are Russian trolls really just bots? So I think people might have different definitions of what bots are, but here we consider bots as computer algorithms that automatically produces content and interacts with humans on social media. So we were curious whether these flagged accounts look like bots or not. So to test this out, we of course use the state-of-the-art API, which is the Botometer API, that returns the likelihood of a given account to be a bot. And so what we did was we ran the Botometer API on about 1,500 accounts that were flagged by the by the logistic regression classifier. We also randomly sampled 1,500 control counts and also ran the Botometer on them as well. And results showed that both of them didn't look like bots, including the flagged accounts, at least according to the state-of-the-art API. So while there was a small difference, the flagged accounts also had an average score below 1. So one hypothesis we thought is that Russian troll accounts aren't just software. So they may likely be more of a software-assisted human that's managing the accounts. So if they're not just bots, we were curious, what do they look like? And so I'm now going to introduce 4 anecdotal findings that the human raters came across when conducting the rating tasks. And again, these are anecdotal, these are not rigorously found results, but we thought it's nevertheless interesting to present because these are results that can't be obtained from making machine learning classifiers. So they had various ways to manage their online identities, and one of them was many of them were managing online identities through their bio. So for instance, one account was pretending to be an American mother or grandmother and wrote it in the bio, but when the raters observed the tweets, they noticed that all of the tweets were of political content without mentioning any kind of son, daughter, or grandson or granddaughter. Next, a lot of them had a normal tweet rate of most political tweets. So for instance, one flag account that was examined by our raters in January 2019 has tweeted over 44,200 times since January 2017. So they tweeted pretty crazily during the 2 years. And next, this is my favorite. So the raters noticed that many of the accounts were using profile picture strategies. So one rater found that the rater used reverse image engineering to discover that one flag account claimed to live in Brooklyn, New York, with a profile picture of a restaurant called Brooklyn Bar and Grill. However, that restaurant is actually in Iceland. So we can see that these Russian troll accounts, these accounts were using fake images that were already published on the web to try to manage their identities. Lastly, some of the accounts were using controversial issues and aggressive behavior. So for instance, one account was calling names or tweeting about controversial issues like immigration or gun control. So these are the 4 behavioral traits that the flagged accounts had. And I would like to wrap up by summarizing that I believe that our work shows that Russian trolls are still likely to be very active on Twitter. And at least according to the state-of-the-art API, they aren't just bots. It's more likely that there are software assistant humans that are trying to manage their online identities in various ways, such as through profile pictures, bios, etc. And last but not the least, I would like to end by saying that through this paper, we showed that we researchers outside of Twitter that don't have access to Twitter's internal data can find suspicious accounts resembling Russian trolls from the outside of Twitter. And therefore, we believe that platforms including Twitter can do the same or can do even better. And this is the end of my presentation, and thank you for listening.